All right, in this problem, I have a ride. It's got a platform and seats are suspended. It's rotating and it's rotating at an angle. And I want to know the speed of each seat. Okay, so if I want to know the speed, it's circular motion. This is going to have something to do with mv squared over r. So first, let's draw a free body diagram for these little things that are spinning around, right? So what forces are acting on this? So there's gravity, and there's also this rope, right? But I'm not going to draw just the rope because that's at an angle. I'm going to break it into components. So that rope, there's a tension. This one, here's my angle, so that means my angle's here. This is going to be the cosine component, and this one is going to be the sine component. So this is ft sine theta, and the other one's ft cosine theta. Okay, so first, right, let's do this in steps. So first, I'm going to find ft, right? Let's do that first. So I can use this because I know what the weight is, right? So I'm going to say net force in the y equals 0. It's not accelerating up and down. So that's ft cosine theta minus fg. So that's the same thing as saying ft cosine theta equals the weight, which is mass times 9.8, right, mg. So I can solve this for ft because I know the angle and I know the mass, and g is 9.8, right? So, okay, so I've got ft. So now, second, I'm going to take my tension, which I get from here, and I'm going to take my r, and I can plug it into my x equation. So my net force in the x is mv squared over r because it's going in a circle, right? So y, it's not accelerating. X, it is accelerating, but it's in a circle, so instead of just ma, it's mv squared over r. So mv squared over r equals ft sine theta. And I know ft, right? I can take that number and plug it in here. So I can solve for v. But, right, the r that I have, I don't really know r, right? So now I kind of have to do a sidestep. I have to figure out r. Okay, so r is this whole distance to here, to the very middle, right? So that means I need to add whatever this distance is here, right? This is going to be d divided by 2, and then there's some other distance right here that I can figure out from this triangle here, right? So, okay, so r is going to be equal to whatever the diameter is divided by 2, so it's that plus this piece right here of that triangle. So this is opposite, so that's sine. So this is L sine theta. L sine theta. So if I do L sine theta, I'll get this piece right here, and that'll give me that. And then I can do the diameter divided by 2, add those two together, that's R. And then I can take R, that plugs in here. Now I can solve for V. Right, I can rearrange this equation because I figured out ft. Okay, second problem is saying if a child of mass 57.2 kilograms sits in the seat, what's the tension in the chain? Okay, so we'll go back to our x equation, right? So our x equation says, or no, our y equation, because that's the easier thing to solve for ft. So from my y equation, ft cosine theta equals fg. Right, so ft cosine theta equals the mass times g. So the question is, what's the mass? The mass is the mass of everything. So the child has a mass of 57.2. So this mass is going to be the mass of the seat plus the mass of the child. You have to add those two together, and that'll give you that. And then I can do like I did in the first part, where I just solved this equation for ft. So fairly straightforward if you draw a free body diagram, right? I draw a free body diagram, I get two equations. There's one, there's the second one. Here I had to solve for r with a little bit of geometry first, but then I could just solve for v.